Alright, welcome back. Generals to another Let's Fix Generals 0 hour to make the best game ever, and we still need to study and investigate the MachO symbols. Yeah. With the assistance with the assistance of ChatGPT, we did not get that far yet. Yeah. Yeah. Okay, so we don't have the morph data. That's the latest revelation we had. Good. So the demangling we have sorted more or less. Reconstruct. Yeah, we don't really want to go that far. Symbol table contains function names, global variables, and their attributes. Symbol table. Okay. So the MachO file does have a symbol table, but no dwarf data. I would like to understand how to effectively use all different kinds of MachO symbols, how their value, what their value means, and how symbols relate to each other. Are there any resources or libraries that can help with that? Let's see what ChatGPT says. Each symbol in the MachO file contains specific fields. Yes. These fields provide information such as the symbol's name, type, value, and scope. Yes. The name of the symbol often mangles. Use a demangler. Yeah, okay. The kind of symbol. Common types include an sect symbol is defined in a section, undefined symbol, absolute symbol, indirect symbol, alias to another symbol. If the symbol belongs to a section, this indicates which section. Metadata about this symbol, such as weak binding or reference types. Okay, that's a description. Represents the symbol address or offset within the binary. Analyzing symbol relationships. Symbols in MachO files often reference or relate to each other. Okay. Undefined symbols. These point to functions or variables defined in shared libraries. Relocation entries are used to resolve the address at runtime. Okay. Defined symbols. These belong to a specific section, text, data, and have meaningful addresses or offsets. Okay. Indirect symbols. These are aliases pointing to other symbols. Aliases pointing to other symbols. Symbol table versus dynamic symbol table. The static symbol table, symtab, contains all symbols in the binary. We only have static symbol. Yeah, we don't have this here. Using libraries for symbol analysis. Several libraries and tools can help parse and analyze MachO symbols. Leaf. A powerful C++ library for parsing and analyzing MachO files provides APIs to extract symbols, demangle names. Well, that doesn't work. Analyze sections. Well, the demangled name, that we know that this doesn't work. Okay, we already heard this here. This is instruction to symbols. LLVM object dump. The n value field in a symbol table can represent different things based on the symbol type. N value is a virtual address of the symbol relative to its segment. Use it to locate the symbol's data or code in memory. N value might be non-zero if it's a common symbol. Uninitialized global variables. N abs. N value is an absolute address or a constant. Okay. Steps to use symbols. Use leaf. Custom MachO parser to extract the symbol table, yeah. Pass all mangled names. Okay, we have that. We have these two covered. Classify symbols. Group symbols by type. Okay. Relate symbols. Cross-reference undefined symbols with dynamic linking information. Actual data or code in the binary. Is it that simple, really? Reverse engineering MachO files. By combining symbol extraction, demangling, and analysis of relationships between symbols, you can make sense of MachO binary and its structure. Yeah, this is the important part. Okay, classify symbol and sect. Let's go to our data. So we also have some additional logs here. Let's look at this one. Hint table. Absolute. Max symbols 1. Relocate symbols. What is this here? Supply center, partial sim tab for source file. So there's somehow a relationship. There's a relationship between these symbols and this file. Yeah. Huh. How is this relationship made? Okay, so it is possible to get a relationship somehow. Yeah. Okay. Symbol extraction, demangling. Is there any library that implements the analysis and relationships between symbols? Is there any C++ library that implements analysis and relationships between symbols? Any cross-platform C++ that implements analysis and relationship between the MachO symbols? Let's see. There isn't a single comprehensive cross-platform library explicitly designed to analyze in great detail out of the box. Okay, that's a bummer. However, you can leverage the following libraries and frameworks which provide foundational support for parsing and analyzing MachO files and symbols. With some additional implementation, they can help you analyze the relationships between symbols. Provides APIs to extract symbols, identify the types, and interpret their relationships. References to external symbols. I mean, that's not very helpful. LLVM object as references. Dyninst. Powerful library for binary instrumentation. Can analyze and manipulate symbols, identify dependencies, and track symbols usage across binaries. Higher level analysis. Call graphs. Okay. An assembly framework for generating code. Capstone. Runtime behavior. Okay, let's look at this dyninst. What is that? Can't be reached. Okay, let's search for it here. Dyninst. Okay, it doesn't say what it is. It just says how to use it. Is there any description of what it is? I hate it. They should, the first paragraph here should describe what it actually is. What this does. What does this library do? Okay, we can't access this website. It probably would explain it on here if that would load. Dwarf. Tools for binary instrumentation analysis and modification. Dyninst API. Dyninst. Introduction. Data flow API. SymTab. Multi-platform library for parsing symbol tables, object files, and debug information. SymTab API currently supports the ELF, okay. Yeah, okay, I hope that this covers our, yeah. And PE, object file formats, in addition, also supports the dwarf. The main goal of this API is to provide an abstract view of binaries and libraries across multiple platforms. An abstract interface provides two benefits. It simplifies the development of a tool since the complexity of a particular file format is hidden, and allows tools to be easily ported between platforms. A set of symbol lists and index symbols within the object for fast looker. Object. Other design goal is to allow users and tool developers to easily extend or add symbol or debug information to the library through a platform-independent interface. Oftentimes, it is impossible to satisfy all the requirements of a tool, as those requirements can vary from tool to tool. So by providing extensible structures, SymTab allows tools to modify any structure to fit their own requirements. Provides a simple set of abstraction over a complicated data structure. It makes it straightforward to use. SymTab table interface. Symbol table interface responsible for parsing the object file and handling the lookup, addition of new symbols. Also responsible for the emit functionality that SymTab API supports. The SymTab and the module class inherit. Yeah, object file on disk or in memory. A symbol class object. Archive. String. Let's make this a little bit larger. String file, SymTab object null, SymTab open file, pass the object file. Find functions. New name. Find symbol. Add it to the library at any point. Pretty name. Simple examples. Oh, we already looked at that. Unknown type. Non-linkage. Is function. It's not yet entirely clear to me how this will be useful, if at all. A powerful library for binary instrumentation analysis. Analyze and manipulate symbols, identify dependencies, track symbol usage across binaries. High-level abstractions for symbol relationships. Stack walk. Okay, we don't need a stack walk. Patch API. Parse API. What is that? Instruction decoder. I don't know how this will help us here. Dyninst. Capstone. A disassembly framework for analyzing code associated with symbols. Assembly framework for generating code. Keystone. Use capstone to disassemble function symbols and analyze their instructions to infer relationships. We don't really want to disassemble functions. Custom implementation. Oh boy. SymTab API. Okay, let's have follow-up questions. Can you elaborate how dyninst can be used for symbol analysis? Binary parsing. Can parse executable files to extract symbols and their metadata. Okay. Provides access to both static and dynamic symbols. We only have static ones. Allowing you to analyze function definitions, variable references, and unresolved symbols. High-level abstractions. dyninst abstracts low-level binary data into high-level constructs such as functions, variables, and modules. Abstracts low-level binary data. Okay. These abstractions simplify the process of analyzing relationships between symbols. Okay. Call graph construction. dyninst can generate a call graph by analyzing function calls within the binary. This helps identify how symbols, e.g. functions, relate to and depend on each other. This helps identify. Okay. Call graph construction. Control flow and data flow analysis. To determine dependencies between symbols and their usages. The reconstruction of variable relationships and function arguments. Okay, we don't need this here. This one is the interesting part, I think. Let's see. Use dyninst SymTab module to parse a binary and extract symbol tables. Okay. The symbol class represents individual symbols, providing details like type, name, and address. Okay. Analyze symbols. Filter symbols based on type, functions, variables, or undefined references. Map symbols to their corresponding sections or segments. Build relationships. Constructs. SymTab. Get all symbols. Construct a call graph. Initialize and parse a binary. Parse the binary. Okay, I mean, we are already this far with leaf, so this is nothing new. Unless this symbol like gives us more intel already. Symtab. Open the binary and pass functions. Symtab, symtab, symtab. Filter symbols with symbol get type to find undefined symbols. Analyze relocation entries to identify how these symbols are resolved. Filter symbols. Map symbols. Workflow for symbol analysis. Please elaborate further on the analysis of static symbols and how they relate and the relationships. And their relationships with dyninst. Okay. Okay, let's see. What is this? No, not static like this. Ugh. Static. Get type. Symbol. Function. Print static symbols. Symbol. Let me see. Search docs symbol. Symbol. Symtab API. I would like to see symbol, what it looks like. Is there no search here? Symbol.h. Yeah. Let's see. Okay, function variable typed. Symbol. So we have a symbol type, unknown function object module section TLS. Okay. Symbol linkage, unknown global local weak unique. Symbol tag, unknown user library internal. Visibility, unknown default internal hidden protected. Okay. Get module. Get type. Get linkage. Offset, pointer offset, local. Get size. Get region. Is in dyn, is in symtab, is absolute, is debug, is common storage, is function, is variable. Versions. Oh, there's not too many functions here. Call edges. I'll be right back. Okay, we are back. Yeah, static symbols. Reconstructing, reference tracking. Okay, let me ask pass API. How can I build relationships between source files and symbols within? Let's see. Reconstructing the connections between the symbols. Group symbols by namespace class. This is not useful. Correlate sections, compilation units. Get relocation entries. Has symbol. Group functions based on their interaction patterns. Okay. I thought that this was a deterministic process because clearly when we look at this file here, there clearly is a relationship here. And I wonder how we build this relationship, right? I assume that this is deterministic and not some heuristic, right? Yeah. To me, this looks like a deterministic thing that we should get out of this. How we get there, I have no idea, but it would be great if we can use a library to get that without building all this stuff our own. Pass section headers and their memory ranges. Map symbols to section using offsets. Yeah, I don't know how this works then. Module. Get all modules. Module source file. Module get all functions. Look at that. Look at that. There it is. There it is. Oh, praise the Lord. If it does what I think it does. Well, it looks like so. Get all modules. Source file, module full name. And then inside the module, there are functions. Look at that. There we go. Okay, this looks promising. This looks promising. Okay. How about we will get this library, try to compile it into the MachO analyzer, and then we try to use it, starting with this example here, and see what we can get out of this. Yeah. My hope is that this SymTab API gives a more high-level view on the symbols in comparison to Leaf. Leaf gives a very rudimentary view on symbols and doesn't really understand these ELF symbols. It looks like that this library here has a better understanding of these things. So we will see what we can get from this. Yeah, good. Then yeah, I will give this a try. What's the time? 52. Yeah. Good. I will give a status update here in the chat. ChatGPT has suggested using dyninst for analysis, for symbol analysis. I will try this next. It looks promising on first. It looks promising on first sight by seemingly having a better high-level understanding of ELF symbols than Leaf does. Well, it's a SymTab. SymTab symbols. SymTab. Okay, good. Then we take a break here. Next session, we try to compile the dyninst. Hopefully, it's easy peasy. And then, yeah, give it a try and see how we can do with it. Yeah. Good. Yeah, then we take a break here. Wish you a great day or night. Until next time. Goodbye.